So just to say a little land acknowledgement to get us started. I'm sitting here on the unceded Musqueam, Tsleil-Waututh, and Squamish lands. Feel free to pop in the lands that you're sitting on right now in the chat box. And before we start today, just wanted to take a moment to reflect on this relationship between flooding and First Nations people, both in the Lower Fraser watershed and North America, Canada, and around the world. And from a settler perspective, just to remark that the systems that have been designed to control water and flooding are also similar systems that have been put to work to control Indigenous people and nations. And many of you might be very aware of this, but many First Nations people were forcefully displaced and restricted to reserves, many of which were in harm's way on floodplains. You can see in this map in orange. And it's estimated actually that across Canada that more than 90% of reserve lands are in the floodplain in flood-prone areas. And this is definitely the case in the Lower Fraser watershed. So just being mindful that while we're doing this workshop and workshop series, that we're thinking about who are the people that are most impacted by floods. A little run through of our agenda today. So we're going to have a couple of framing presentations from myself and then Matt from City of Surrey. Then we're going to have some dialogue in breakout groups about what are you seeing as the biggest problems that you're having when you're working on floodgates. Then we're going to have a solutions presentation. I unfortunately learned this morning that Leo Kuntz will not be able to join us, but I've whipped up some slides based on conversations that I've had with Leo from down in Oregon, and I think it will still be, I'll do it some justice about the kinds of solutions that he has. And then we'll get into brainstorming solutions to the problems that you guys have identified in the earlier dialogue. And then we'll just basically talk a little bit about any next steps and closing up. And then just another reminder here, if you're just joining us, please do rename yourself in Zoom with your name and organization. You can find the renaming button by clicking on the participants tab and then finding your name, and then hovering over the little hamburger and clicking the rename button. Okay, welcome back, everybody. Just to move us along here, just wanted to talk a bit about why I'm hosting this workshop series. And for some of you that might not know me, so I work on a project called the Resilient Waters Project that's been running since 2020. And it's really looking at this opportunity and overlap of primarily these three issues, which is basically that we have a lot of aging flood control infrastructure going on in the Lower Fraser watershed. We have climate change and unpredictable kind of flood risk that's coming our way in the future. And we have basically a salmon crisis and a loss of salmon habitat in the Lower Fraser watershed. And all three of these things kind of combined make a really great opportunity to find things that we can do differently. And I firmly believe that there's a lot of great ideas and knowledge in this room, and there's just kind of a lack of time to do it together. So the Resilient Waters Project is really largely based on the work that Lena Aziz, who is with us here today, and the Connected Waters program that Lena's been working on since 2016, essentially looking at flood control infrastructure up and down the Lower Fraser watershed, and some mapping work they did in 2018 showed that about 156 flood control strictures and 250 kilometers of dikes are blocking roughly 1,500 kilometers of salmon habitat. That is really important for particularly juvenile Chinook and coho salmon that they use as refuge habitat. And further research that was done by Raincoast Conservation Foundation released a couple of years ago was actually showing that about 85% of floodplain habitat was lost. Now, I mean, this is quite a salmon-oriented perspective, but we're also conscious that there's lots of other kinds of benefits that can come with protecting floodplain and just being more conscious, protecting communities, protecting food security, all these other things too. So the Resilient Waters Project followed up on that work by doing a lot of engagement and meetings to understand where some of the best opportunities might be to make some improvements on flood infrastructure. So this is a map of sites, essentially a short list of 25 sites you can find on our website. And they actually all have associated data that's been collected on salmon abundance and habitat. But we're always open to learning about more. So if there's sites that you're interested in having a look at or collaborating on, please do reach out. And basically our role in Resilient Waters is to play a supporting role and facilitate cross-sector meetings that might not happen otherwise. Put people together in a room to talk about shared values and then provide some technical guidance or support or a capacity boost to help some of these projects get off the ground. As part of that work and in the relationships that were made in kind of mid 2021, I brought, or a few of us started joining together some experts that wanted to see more progressive flood management in the Lower Fraser, more proactive. And we came together and then not long after we had the November 2021 flood events, and our group here, which we have been calling the Build Back Better Together Collaborative. We recently are shifting our name to the Lower Fraser Floodplains Coalition. Have been meeting since November 2021 in a pretty serious way to respond to all the needs from those flood events and ensuring that we don't have kind of the same, or working towards not having the same kind of outcomes and being more preventative and proactive. Yeah, so a group of academics, consultants, NGOs, and really important to point out that it's with leadership and guidance from the Indigenous-led Emergency Planning Secretariat, and particularly their chair, Tyrone McNeil. Just to point out quickly, and some of you may have been in attendance, that we hosted a forum in July last year where we shared 5 principles that we thought would be important to be kind of the basis of how we do more progressive flood management. We included reducing risk and adapting to climate change, and a key part there is understanding risk and understanding what we know and what we don't know, and responding accordingly. Advancing reconciliation, so moving beyond a duty to consult, but understanding that First Nations are a key part of the solution, and also that they have rights and title that are very important to recognize, and increasingly being proactive about how we understand DRIPA and what that means for everyone. And then ensuring that salmon are thriving, and in that way, salmon act as an important proxy for lots of different ecosystems and water quality indicators, and a lot of important part of economies and communities, culture and thriving. So, and then making sure that everybody is part of the solution, and believing that everybody can be part of the solution. And I think particularly important to point out that those that are the most impacted are helping to inform the solution. In this case, as I referenced before, agricultural producers and farming associations and First Nations, but also local governments who are working on this and the citizens that they represent. And then finally, supporting sustainable economies and resilient communities, and thinking about things like food security, ensuring that critical infrastructure can still support those healthy economies, and that they aren't being damaged. So trying to take all of these things into account. So moving on to, so why a Designing for Flood Resilience workshop series? Well, since the Resilient Waters project has begun, what we've really noticed and seen a desire for in our conversations and in the research is that there's a real desire for this improved information sharing and collaboration, more shared understanding of what best practices, guidelines, regulations, and processes already exist or might need to be created or can be improved upon. lots of opportunity to innovate and prototype new solutions for the future, but we need to carve out some space to do that and to do some targeted work on it. An opportunity to build cross-sector relationships and multidisciplinary approaches, and then building shared values for a better and more flood resilient future. And I'd also just say that in our research, we're coming across the importance of these kinds of groups and cross-sector kind of gatherings more and more, and we're really inspired, particularly by the Washington State Floodplains by Design program, which has this as a pretty core part of their work, supporting a peer-to-peer learning network. So then why floodgates first? Well, they're the most prolific piece of flood infrastructure in the Lower Fraser. There's definitely lots of room for improvement and innovation. Many are already past their life, and the solutions are needed now. And then more of a jokey answer is, how can you say no to this guy? Matt Osler asked me if we could start with floodgates. So why not? And they've got a lot. So just to quickly to talk about some floodgates, these are some animations that Lena and I have worked on with a few folks, including Case Lockman at UBC Coastal Adaptation Lab. We have these for all sorts of types of floodgates and pump stations and other nature-based solutions. So you can go visit our website to find more about these. But just to show off, this is kind of primarily oriented around the problems that occur with a top-mounted floodgate for fish passage. But of course, these also cause water stagnation that creates low quality water behind on the creek side. Invasive species thrive in these kind of high temperature, low oxygen environments. So it's not good for really ecosystems, but they also create flood risk because they're usually too limited a passage for the creek flows that are needed. There's sticks getting caught in the gates and not providing the flood protection that is required. I'll just show off this one of the side mounted gate, which is maybe an improvement, you could say, on the top mounted gate in a lot of ways. Less head differential required, more water flow, but we still have these problems of debris getting caught and being able to rely on these to also provide that flood protection. So, I mean, this is just to give a sense with these animations of, if you're not familiar with these kinds of flood infrastructure. Well, with that, I'm going to hand it over to Matt to present. So I'll stop my screen share, and Matt, if you would like to unmute and share your screen.
Great. Thanks very much, Dan, for convening the workshop here and providing that overview of some of the challenges facing the region. Before I get started, I'd like to acknowledge that I'm working here on the Coast Salish people's traditional territory, including the Semiahmoo, Katzie, Kwantlen, and Semiahmoo peoples. And the overview that Dan presented didn't go into the detail of the Nickel, Meckle, and Serpentine River, but this map here shows most of Surrey's flood control infrastructure. It's about 100 kilometers of diking and about 300 flap gates. About 90% of the flap gates are the traditional top-mounted gates, and the rest are side-mounted. I don't want to get too into the weeds of the technicalities, but just in general, Surrey has a lot of upland that drains into land below the high tide mark that's protected from flooding or controlled the amount of flooding through pump stations, flood boxes, ditches, dikes, to get the water to funnel out into the ocean. So the flood boxes work in conjunction with pump stations to allow water to drain through a dike. And in Surrey, this land is predominantly agricultural, so it is subject to flooding up to 5 days for our 1 in 10 year design storm, and that time period allows progressive drainage at low tides and for distributed pump stations to get the water off the land into the ocean. So I just wanted to give people a little bit of perspective on what the infrastructure actually looks like. So the flood boxes tend to be very close to the low water level, so they can only be seen from the riverside at a very low water. And most of the existing infrastructure is metal pipes with cast iron gates that look like this. And then there's also private infrastructure as well that farmers have constructed over the years. Some of the newer flood boxes were mounted on bin head walls like this one. Common problems include mud and vegetation encroaching on the actual gate and causing issues with the gate not able to seal tightly. At our pump stations, we also have flap gates on the discharge lines. Some of them have head walls. Other times they use these timber frames to provide structural support to the pipe. When there's no water in the pipe and when the river is high, you can get buoyancy force. So this timber structure ensures that the pipe itself doesn't float or rotate out of the ground. One of the common breakdowns is the older metal pipes were protected with a tar that's delaminating and then chipping off and then exposing the steel to oxidation and corrosion. We also have some flood boxes that are mounted on a fiberglass frame like this one. So you can tell visually by assessing this that this looks in fair condition. We do try to actually touch the pipe and confirm that it's not brittle or flaking away the coating. But it's amazing how it can pass sort of a tactile test like that, and then the very next winter massive corrosion can form. And we find that once even just a small pinhole forms in the metal, it quickly deteriorates. And so in the course of just a few months, it can go from a pinhole to half of the cross section of the pipe completely disappearing. So some of the challenges we have with maintaining this number of flood boxes obviously is corrosion. When in the winter, say if there is a failure detected, we often only can put a temporary plug in the pipe or backfill it temporarily to close it. So it needs to be scheduled for replacement later in the summer when the weather's better. It can be very difficult to actually see the pipe. So even on a low water inspection like this one, it's not really possible to accurately assess the condition. The other thing is, historically, many of the flood boxes were constructed before pump stations were constructed. So with the construction of pump stations, it does reduce the benefit of a flood box from a drainage perspective, but it still does provide some level of service by having a flood box. So the challenge is how do you make that determination of whether the risk of a failure outweighs the reward of having the flood box there. I wanted to touch on one approach for those not familiar with municipal engineering is we do, where possible, standardize our infrastructure. So Surrey is part of the Master Municipal Construction Document Association, and it has many standards for typical infrastructure a city might have, like street lights, sewers, roadways, that type of thing. And then the provincial government also sets out some high-level guidelines for flood protection, but neither of those two standards get into the details of flood box construction. So to fill some of those gaps, Surrey publishes its own supplementary standard drawings, and this is an example of a driveway head wall. And you can see there's a fair bit of detail on one sheet, and then that allows driveways in Surrey, for example, to be standardized. So for flood boxes, we haven't included a standard in our published documents, but we do internally use a template design that I'm showing here that gets into a lot of detail on constructing a flood box. And we're using this for over 5 years now to determine the specifications for new flood boxes. And over those years, we've progressively improved upon the design. And what we found is often, like, one site will have very challenging conditions during construction, or the weather will be poor during construction, and that will be sort of a weaker flood box. And so we have seen some failures over the years, and we've learned from those sort of what the weak points in the design are. And over the years, we've sort of reinforced it and tried to make it as reliable as possible. So having a standardized approach has helped us in the sense that we're less likely to make the same mistake multiple times, because we can systematically improve on the design. It's easier for the construction industry to sort of anticipate what materials we need, and it makes the contractors more confident in bidding the work, because they know that the design hasn't changed a lot. So they have that comfort that, well, they did this last year and they knew how long it took and what the level of effort was. And it's also helped streamline our permitting process, because then the regulators are familiar with the work, and they don't have to refamiliarize themselves with a new design each permit application. One enhancement we were able to incorporate as well is, as I mentioned, the water often doesn't get low enough to see the bottom of the pipe. So the design allows for being able to place a piece of plywood or a series of timber beams in, and then we can pump out the water to get a dry work area if we have to lubricate the gate or repaint it or do any kind of maintenance to clean the outfall. And then the consideration is, with sea level rise, the water level will gradually increase. And so if today it's difficult to see the bottom of the pipe, with 1 meter of sea level rise, it'll be impossible to see the bottom of the pipe. So having this provision allows us more flexibility in the future. So in terms of how we actually replace a flood box, I just wanted to introduce some challenges to the group. So a lot of the materials are relatively specialized. So we do find that up to 1 year lead time is needed to secure some of the components. As I mentioned, the water levels fluctuate, so we need to put in a cofferdam like this one to allow doing the construction and excavating through the dike. Some general sort of considerations. Of the 300 flood boxes, we had a wide variety of sizes, and that made it difficult to stock replacement parts for them. So we've standardized to just 3 sizes now. We've limited to 1200 millimeter diameter because the larger pipes aren't available in corrosion resistant materials like HDPE. So our preference is to keep the size to what we can use corrosion resistant materials in. Some of the challenges we've had is we have found like a reliable gate supplier that had good performance, and then suddenly they'll discontinue their product or leave the industry altogether. So that's made it difficult for us to sort of keep stability in our design and our spare parts. We certainly had, with some manufacturers, challenges with getting a reliable seal on the gate. So that is our top priority, is if there is a flood box through a dike, we want to make sure that it can seal. Until we get comfortable with a new supplier, we do make sure that we video inspect the outfall of the flood box to make sure that it's not leaking. Because it's not really practical to test the volume of water that's leaking through such a large pipe, especially when it's 10 meters down in an excavation and 20 plus meters from daylight. So by using a crawlable camera going right to the face of the gate, we can do a visual inspection to prove that there's no leakage. And then lastly, just some of the design considerations that we account for in our template design is the highly corrosive soil and water. The fact that the remote locations, we don't want to have to bring in a crane to handle the equipment or the materials. So everything has to be light enough for an excavator to lift. And then the pipe connections and the transition points have to be resilient to high differential settlement because the ground in the floodplain is made of very soft soil that can differentially settle and cause the system to fail if it's not accounted for in the design. So I wanted to share, this is just an example of how industry helped innovate into our template design. So Langley Concrete was able to modify their standard head wall to make it lighter weight by having these cutouts, so the excavators could manage the lifting more easily. It had special details such as having these anchors precast into the concrete, and then for climate change, the ability to accommodate a cofferdam right into the head wall was an example how over a period of years we were able to improve with a custom solution. So one thing I'll touch on is just the cost of the materials and sort of the volatility in the market. So where possible, we do try to specify multiple pipe material types so we can get competition between suppliers. And then unfortunately, just each pipe material has a slightly different diameter. And so that does cause us quite a bit of compatibility issues with making sure we have the right connectors and the right head wall to interface with such a wide range of materials. But this is just an example of how in our standard, we were able to sort of pre-plan all those potential combinations of materials to ensure proper compatibility. In terms of cost, this is just a breakdown of where our costs for replacing a flood box are attributed to. So about half the cost goes to the actual general contractor providing the labor and the excavator and the cofferdam materials. And then the head wall costs about 10%. The flap gate, pipe, trucking, backfill, pilings are all kind of in the 3 to 10% range individually. And then the engineering costs about 10%. So that's for the 750 millimeter diameter pipe. The material that's most sensitive to cost for going to a bigger size is the flap gate. So to go one size larger costs 20%, and then relative to the 750 to go 2 sizes higher costs about 70% more. But from a hydraulic perspective, going a couple sizes larger provides, several times more flow capacity. So these are just some of the trade-offs that we weigh when we decide whether to go with, say, 2 750 millimeter diameter outfalls or 1 1200 millimeter diameter. So yeah, I think that's enough background on just sort of some of the technical considerations in designing and replacing and managing so many flood boxes. I wanted to foreground a current challenge that the city has. So we have a canal called Eugene Creek that outfalls directly into Boundary Bay, right on the border of Surrey and Delta. And it uses a combination of side-mounted flap gates and top-mounted. So the top-mounted flap gate is performed reliably, and it's still intact from about 10 years of service. However, the 2 side-mounted flap gates, one of them has failed and has had to be temporarily blocked, and then the other side-mounted gate is on its last legs, and we are expecting it to fail imminently. So we've started planning a replacement of these gate structures. So just wanted to highlight a few unique challenges of this site. So being on the ocean, it's a particularly corrosive environment. It also is subjected to floating debris on the ocean directly contacting the gate, or potentially getting wedged into the gate to block it from closing properly. The mud itself tends to try to flow into the culvert and block the actual outflow, but then when we have a storm flow, it self-scours. So one of the design details is a chain on the gate to prevent the gate from swinging too far open, because if it swung more than 90 degrees open and there was, say, an onshore wind, then that would preclude the gate from closing. So that's a unique feature here. So if this gate was still being manufactured, it would be straightforward. We could just order a replacement gate or replacement parts and retrofit it. However, the gate is no longer carried by the supplier. So that's the challenge, is what to do about this outfall. Because these flood boxes are so low, it's difficult to see them. This is a photo at low tide. We can see the top mounted flap gate, but then underneath it are 2 smaller side mounted gates. So this cross section here shows the where the gates that need to be replaced are, and then in this view here, you can see that this is the gate that's been just closed permanently until we have a replacement gate, and then one still remains in service. And then just wanted to leave the group here with just bigger photos of how the site looks. So this is the coastal dike here. It's armored with riprap, and then the channel that the water takes kind of self-scours this channel in the mudflat, and then you can see the higher larger pipe, and then the 2 smaller pipes are submerged underneath it. So Dan, I'll hand it back to you.
Great, thanks, Matt. Yeah, that gives us lots of context. And if you're not from the engineering world, now you get a window into what engineers are thinking about when they're talking about things like floodgates. So, I mean, this is all part of it to encourage our kind of multidisciplinary thinking. These are a lot of considerations that go into these kinds of things. So thanks, Matt, and really setting the table for our first dialogue, which we're going. Without further ado, I just want to get us into a talk about some solutions. Unfortunately, as I mentioned at the beginning of today, I was hoping to have Leo Kuntz from Mihalem Marine Manufacturing join us to talk about the work that he's done up and down the coast, but he was unable to join. Actually, he messaged me this morning to say that he's just got too much stuff going on, preparing for some work this spring. But I've summarized some of the work he's done. So I'll push us along here. Just to highlight some of the stuff that we're doing with Resilient Waters. One project that we're undertaking with UBC Pacific Salmon Lab with Scott Hinch and Coquitlam First Nation and Metro Vancouver Parks folks. We are running this project looking at 3 different floodgates. One is a kind of crappy top-mounted gate you can see in the top right that is not really doing its job and old. A really new and very unique kind of style of floodgate called a self-regulating tide gate at the bottom left that actually operates with sensors to open and close on essentially on timing and sensors. And then another gate as a control reference site, which is basically just a chained open gate. So we have 1 good year of data. We're still collecting data. So preliminarily, we can say right now, oh, and I should share something about the technology. You see in the bottom left, there's those wooden frames with the loops. These are actually antennas that are picking up what's called a passive integrated transponder tag that have been inserted into juvenile coho salmon and then dumped outside those gates. And every time they pass through those loops, we actually can detect down to the individual what they're doing, if they're moving in through the structure into the channel behind them or coming back out. And so what we're already learning from this first year of data with 1,500 salmon that have been tagged is that about 60% of the salmon that are dropped in front of the self-regulating tide gate are moving through, whereas only about 7% of the salmon at the crappy gate here are moving through. And then compared to the gate that's chained open, we're getting something closer to 80% of salmon are actually moving through into the side channels. So some exciting preliminary results. We still have another year of monitoring to do, and we'll probably continue to monitor since we've got all this cool equipment up and running. But stay tuned for more results on that. I believe there's only 2 or 3 of these self-regulating type gates in the Lower Fraser right now. I wanted to highlight some of the cool work that that's happening in Oregon. So, and while it would be great to have them present today, it's also just, I want to just highlight it very quickly. In Oregon, they have a Tide Gates partnership that goes statewide. It's coordinated by the State Watershed Enhancement Board. It actually originated from concerns that cattlemen's and the Farm Bureau were expressing about the need for fish-friendly gates and how much cost it would take to replace them and upgrade their gates. In particular, I mean, you can see why. It's estimated that there's about 2,000 tide gates on the Oregon coast that are sitting there. So many need replacing, lots falling on farmers' backs, which is not really fair. So that's why they started up this program. So they've developed an inventory and mapping tool to prioritize which gates need replacement. You may even have the individual that's in charge of that prioritization tool for our next workshop. A little teaser. And this partnership group, which is, again, coordinated by the State Watershed Enhancement Board, plays this key intermediary role between permitters and projects to help move things along. There's also a fund that's been set up to help pay for some of these replacements. They're still kind of looking into how they can expand the scope. But yeah, a promising example to point to in terms of how you can set things up to alleviate some of the problems that we even saw, we're noticing that permitting in particular has some shortcuts, but they still have their challenges for sure with this group. One that I want to focus on here, unfortunately, again, Leo is not with us today, but Leo is a pretty unique guy. And I know that we have lots of great manufacturers here in the Lower Fraser here with us even today. We've got the Langley Concrete Group, which are doing some really great work. But the reason I wanted to feature Leo's work is because it's quite unique. I don't think we have anything quite like what he's doing. And he's actually a boat builder turned flood infrastructure creator. So, and he's a former commercial fisherman. So he's got an interesting background. He's been working on this stuff for over 30 years. He's installed hundreds of floodgates in Washington, Oregon, and California. And he only uses marine grade aluminum. So, I mean, he's very focused on the tidal aspects of things. So, but these are kind of very durable approaches because of the use of this marine grade aluminum. As you can see here, he's developed some pretty large kind of gate arrays and lots of different solutions that he's been testing out over the years. You can see in the bottom right, like an array that has a top mount and a side mount. That top mount also has some floaty buoys that help the gates to open a bit more. You can also see in the top right, these much larger kind of gate designs that are an array of top mounted and side mounted. And then in the left side, you see this kind of thing with a larger door for those more extreme events, but then a smaller door that's more often open to allow that kind of water flow and passage. But the real kind of cream of the crop solution that Leo has developed is called the muted tidal regulator, which is essentially, you can see in the background, a gate closing as this kind of air-filled container lifts up. And that's because it's all oriented around cables. And as the tide comes in and pushes that buoy on the creek side up, it actually helps to close the gate. And then as the water levels lower and the water starts to want to flow out of the side mounted gate, then it actually releases the buoy again so that the gate opens and you go back to this kind of state. So a pretty interesting design, all oriented around mechanics instead of sensors. It's a very analog kind of design. And he's found that this is like the most reliable in his experience and uses these more and more. You can see here like a little bit more about how that works from a cross-sectional view. You can see the buoy on the right-hand side on the creek side or the slough side, and then the gate on the left-hand side or the ocean side. The series of cables that you can't quite see, but they're basically working on tension and things like that. Yeah, so a very interesting design. On some of those bigger arrays, this is actually what it looks like. So a lot of interesting and complicated mechanics. Again, I'm not suggesting that this is what we should be moving to, but just pointing it out as an interesting example of the kind of technologies that maybe aren't even being considered here. Just somebody else that's also working in a similar mechanical design. If you really want to do a deep dive and you're an engineer and want to get into this stuff, this Jeff Jewell has some pretty, I would say, controversial opinions and points a lot of fingers at the intellectual property problem and talking about kind of ideas getting stolen and things like that. But he's also designed a gate that operates purely on mechanics of and tension. And you'll see here pictured basically like a pulley system that allows the gate to open once it hits a certain resistance. So yeah, interesting possibilities here that are quite cost effective. Again, questions of maintenance and understanding how they operate is another thing. But there's a lot going out there, especially stateside, about how these things can operate and kind of maximize fish passage and water flow. So I know that's a relatively quick dive into different solutions, and as much as I'd want to open it up to other folks for all of these other possibilities, I'm going to push us on to going into our breakout groups and talking about problems that you want to cover. We're going to probably go back to the mural board a bit more. Essentially what we're going to be doing here, again, you'll be in different rooms because you're self-selecting. You can ask clarifying questions to your table facilitator about the problem that you're trying to tackle. And then you'll have that time to do silent work in sticky mode, and then lots of time for discussion. And then hopefully if things are going well, we'll have some time to report out. But there's a lot of groups today, so we'll see how that goes. And I'll be watching the stickies. So a few little like tips on typical brainstorming. Let's just say all ideas are valid here. There's no bad ideas, so go wild in the sticky notes at least. When it comes time to the conversations, then working to focus your conversation on some ideas that you want to explore. We're really just sourcing all these ideas and as a gauge to find out what kind of things should we pursue and keep looking into. And it might be that you guys want to look into these further, or will look into them further. But I think it'll be really telling to see what people want to happen. With that, I'm wondering, Felicia, are you feeling ready for popping people into the breakout groups? Okay, welcome back everyone from your conversations. I hope they were fruitful and learned some things or came up with some interesting ideas. Before we get into some table report outs, I did want to so I got a message from Craig Sutherland, who was involved in the Colony Farm floodgate work. And I just wanted to point out a quick clarification that he sent to me, which is that this floodgate is actually, let's see, here we go. So the floodgate that I was referring to on this bottom left image is actually passive floodgate. That does not require power, but is instead operated by hydraulic fluid, essentially. So it is passive, but it uses a hydraulic fluid system instead. So interesting. I did not know that, but a cool idea. There's probably some people here that could say more about that. And I did want to highlight something else, just because I am familiar with it and I don't, but I did not prepare any slides for it, is just broadly speaking, the Floodplains by Design program, because of all the interest in the permitting problem, maybe just to point out, this Floodplains by Design program is a pretty cool one down in Washington State, where they basically developed a granting program that basically sees that you have to have all these things met, basically like early collaboration and partnerships and engagement with tribes and First Nations. Having to have fish friendly, but also agricultural concerns and flood risk like all addressed. So they use this granting program to really kind of bypass a lot of these permitting needs. So yeah, if you're interested to learn more about that, we'll definitely have a workshop about that will include a presentation about the Floodplains by Design program more. But without further ado, I want to hand it over to you folks and see if there's anybody feeling brave enough to step up and report out first on what their group talked about.
We can start the designing for fish needs and ecological values. So we spoke a bit about giving some of the fish habitat back, or generally just manage retreat to allow for wetland habitat restoration for the purposes of conservation, as well as flood risk management. But there was a comment about the reluctance of, I think, municipalities to allow for like kind of making room for flooding or making room for the river. I'm forgetting exactly why there was that hesitancy. But yeah, like designing setback dikes where possible. Something we also spoke about was fish-friendly designs that allow for fish passage. So when replacing old infrastructure, being more mindful of that. Lena, is there anything you want to touch on?
Yeah, so with regards to that comment from about the hesitancy, was it's fine to create setback dikes or remove floodgates where it's safe to do so, but where there's already a lot of infrastructure, such as industrial or housing, then obviously you need to take those values into your considerations as well. There was some conversation around, well, there was a lot in the sticky notes about collaboration and working with other partners, bringing in citizen scientists, encouraging more public engagement in these works, as people often don't think about flood infrastructure. You walk in a dike and you're just like, oh, this is a really nice flat trail, but you're not really realizing the important structural work and protection work that's happening there, and never really noticing gates. So incorporating more posters or QR codes or audio tools, some way of engaging the public and bringing more awareness to this work, and why it's important to not just protect our communities for resilience, but also the multiple benefits that would be protected if we're doing things a different way, and therefore educating people on that. So that was a really good point, I thought. What else came up? Ensuring adequate training of staff on operations and maintenance of said infrastructure is also really important. So there's some really good, everyone contributed really well to our stickies, and I'm sure those will be shared through somewhere later. Those in our group, anything we missed? Feel free to add it to the chat.
Yeah, thanks, Lena and Rachel. Who feels ready to go next?
I can go next.
Thanks, Philip.
So our group was about collaboration and engagement, and across our group, we were discussing how it's so important to identify key stakeholders initially and make sure that all the key stakeholders are at the table, especially because oftentimes it has happened that there's more of an engineering approach towards these projects, and then environmental factors are seen as phase 2. And so there was consensus in the group that it is important that all the parties are at the table earlier on, and especially different levels of government, including First Nations specifically as well, to make sure that everyone is at the initial planning stages rather than being the recipients of an engineering design that's already developed. And so at that point, some of the contingencies are that there's a lot of money that's already spent on certain designs by engineers. And so when it goes to environmental factors or biologists or different agencies, then there's less likely to implement the changes than we had all those people at the table, make sure that it's a collaborative approach, but at the same time, making sure that all the voices that are at the table, that they're implemented and in the initial design, and that the voices are actually heard and not just forgotten, but actually remembered, and the points that were given by all different stakeholders are actually incorporated in the initial design, because then that saves time and money. Because if we just focus on an engineering approach and don't focus on the collaboration and engagement with all the other stakeholders, over time, we will be losing money and time, because we have to go in and fix everything that was done, not having a holistic approach. And so just the importance of that is mostly what we were discussing, unless I missed something from anyone from our group.
Nice, thanks, Philippa. Yeah, and feel free to clarify any points in the chat. Who's feeling brave enough to go next?
Maybe we can go then. So we were group 1, and we started off originally in ops and maintenance, and that kind of then transpired into permitting, but we've kind of grouped a couple of solutions for both of these topics. So in terms of permitting, the main theme that kind of came out of it was timelines. Timelines are crucial, and it's important to ensure that you are talking about it very early on, not at the implementation phase, but very much at the design phase. You can't really go forward if you don't have a permit in place, and ensuring that all active stakeholders are just kind of echoing Philippa's point that, stakeholders that are involved in the project need to be heard, need to be voiced, and having space for First Nations communities that are impacted by the project, near the project, have a vested interest in the project, whatever they might be. They need to be heavily involved. It's important for governments involved in that process to actually use OCAP principles when they are working with Indigenous communities. At the same time, ensuring that because there's multiple ministries involved, ensuring that there's cross-agency collaboration. Even if it's one representative, there needs to be someone at the table so that there's some sort of active conversation going on. Partnership building is really important, having governments from multiple tiers of government, so whether that's local, federal, provincial. Often I think we all know that governments are often siloed, and so it's important to bring those current actors at the table from the get-go, like even if it's an idea before an actual plan or funding or anything has been, allocated to the project, ensuring those actors are at the table, ensuring that there's legislation that allows for the implementation, not just having a project. If it can't go anywhere, there's, it's hard for the actors involved. Maybe moving on to some of the operations and maintenance solutions that came up. Tracking maintenance activities is important. Developing a process to kind of flag some of the problematic gates, ensuring that you're sending out teams, there's ongoing communication with the engineering team and the maintenance team to ensure that none of these floodgates are getting eroded. I guess, engagement was a really big one that kind of came up in both areas. Just wondering if there's anything else from our group. Maybe I'll ask Devin or anybody else from our group who thought there's something else that we should probably include. I welcome you to type it into the chat, or feel free to kind of voice up right now if you'd like to, but I think that was one of some of the key points from our discussion.
Awesome, thanks. And I think we have 2 more groups to report out, is that right? Yeah, so 2 more.
I don't mind going next if
Thanks, Kim.
it's okay. Okay. So our group was solutions for funding costs and logistics. And so the first one was, we thought about talking with other jurisdictions with experience that could guide our future projects, having clearer processes for grant applications, tying into new projects or new developments or dike improvement projects, engagement with the public to convince them that funding this is important, because oftentimes people don't really understand what these projects are, why they are important, and might not see why their tax money is used in this way. We also talked about how we need more time on pre-design to understand the full cost, so we don't end up going over budget. And that can include engaging with some experts or things like that. We also talked about facilitating the implementation of pilot projects. And if anyone from my group wants to expand on any of those, go ahead.
Okay.
Really good.
Dan, I can do a quick summary of the standardizing design and functions. So yeah, we had a good wholesome discussion. We all kind of agreed that having standards and guidelines would be helpsful, but there's a lot of reluctance at the provincial level to do that, just because of not stepping on the toes of qualified professionals and just the sub-regional perspectives that go into these things. One kind of, a couple sort of interim steps we talked about was maybe we can focus on some guidance for rehabilitating existing flood boxes to buy some time until a more permanent solution is developed. Another one is just when requesting design services for flood control infrastructure, just having a few paragraphs specifying sort of the considerations that should go into a flood box, because a lot of times it's kind of an oversight or just sort of a side issue of a much bigger project. So just bringing attention that there's some specific design needed for a flood box could just advance the state of practice, and until a more national or provincial standard could be developed. So I think that was it, unless anyone else has something from my group.
Awesome, thanks. And I think that's all the groups, is that right?
So Dan, I think our group did permitting as well, so we doubled on that one.
Nice, yeah.
But maybe we can just do a brief overview of what we discussed. So similar to what Sherry was talking about, we looked at like streamlining the process. So it was mentioned how the Dutch do it it's a more centralized control and is a single timeline, which makes it a bit easier to plan. So trying to strive to get there. We've seen that ministries sometimes have a hard time collaborating, which makes it difficult for planning and getting permits approved in time. And also, while we strive to centralize something, making sure we get First Nations priorities and small groups all considered in the big picture when we go macro, like keeping everyone involved. And doing that is mostly enhanced with effective communication, making sure everyone's speaking the same language, whether it's engineering or lawyers or First Nations representatives, making sure we express what we're trying to do from the get-go in the design by with effective illustrations, Gantt charts, and that communication being supported by effective legislation to support First Nations and everyone involved. So that's, if anyone wants to step in and if I missed anything.
Awesome, thanks, Javier. That's great. Sounds like some really good conversations. So we're coming towards the end of our time together. I'm just going to pop up just the last slide to talk about what's happening next and what we're doing with this information. So just bear with me while I bring that up. Yeah, so essentially, we're going to take what we've heard from you today and then synthesize and summarize all of that info, create some summary or create a summary report for this one, but as well as for this ongoing series, we'll continue to do exactly the same and create summary reports for each. We'll share a recording of the presentations and share the actual presentations too. I think that's cool, right, Matt? You're open for sharing your presentation?
Yeah, no problem.
Sweet. One avenue that we are looking into is a partnership with the National Research Council, who could help us to basically do some research and standards development with them. And there's some pathways that we can go into doing that, whether it's floodgates or other aspects too. I don't know if, do you want to say anything more about that, Matt? Because you've been working with them on the Living Dike project and how that works.
Yeah, sure. I can just take a couple minutes here. So the folks at the National Research Council in Ottawa have quite a breadth of technical capacity and knowledge from modeling to actual testing to connections to the Canadian Standards Association. So for Surrey, we had a similar sort of flood control environmental concern with armoring dikes with riprap, and we were able to get pilot funding to do a living dike using natural vegetation as an armor, and having the National Research Council sort of doing testing in their lab and modeling helped us optimize our design and just give us more assurance that the city wasn't taking unnecessary risk in proceeding with the pilot project. So that model's worked well, and I think it could also work well for this other complex challenge of fish passage through flood infrastructure. So I think, yeah, it's still early days in sort of scoping how it could go forwards, but I think all the input today will really help provide some direction and guidance on how to move forwards with those discussions and hopefully securing grant funding and so on.
Yeah, cool. Thanks, Matt. Yeah, and then just to continue on talking about the interest and possibilities for prototyping and piloting new solutions. If that is something that interests you, I think there's a lot of willingness from governments right now and funding opportunities. And so please, if you are interested in doing that and you have an example of something you'd want to move forward, do feel free to reach out to me. And I can try and play a connecting role on that. And oh yeah, the other thing is to pop a little poll out there. Interested in what folks are most wanting to see from this workshop series. Here are a few examples of topics that we're looking at pursuing. So yeah, please take a moment to pop your votes in on which topics would be of most interest to you. That'll help inform us the direction to go. I'll just wait for a few more people to pop their votes in there. Looks like pretty even smattering, which is great. It means we're on the right track. Yeah, and if you have another option that you don't see there, feel free to type it in the chat and we'll capture that. Lots of desire for dikes and dike alternatives. Okay, I'll end the poll there just so everyone can see the results. So that's basically it. Yeah, pretty even interest across, big time interest in dikes and dike alternatives and integrated floodplain management. So that's great to hear. And then I'll also just pop a feedback form into the chat. If you do have, this is a pretty short form. If you have any feedback on how we've done this is our first time, so it would be really helpful to get some feedback from you guys on how you think this day went. If you'd like us to take a different approach, less dialogue, more presentations, that kind of thing, yeah, that would be really helpful to guide us in how we set up these future workshops. And maybe I just wanted to give Matt a chance to share any reflections if you want, Matt, on the day and thoughts.
Yeah, sure. Thanks, Dan. Yeah, no, I think this opportunity that was convened today to bring so many different perspectives on this problem was valuable. And my group, you know, just having the different professional disciplines speak and sort of exchange some of the language that they use and perspectives was valuable. I think, you know, I learned a lot and you know, other people in the group learned other people's perspective. So that was really helpful. And we don't often get that opportunity on specific projects to really do a deep dive into the issues and the barriers. So yeah, I was really pleased to see that happen today and just how much breadth of interest there was here with I think close to 100 at the start of the workshop. Speaks to, you know, that this is a regionally important topic and hopefully just the start of much more work to solve some of these tough challenges. So thanks for everyone's time and look forward to the next in the series of workshops.
Yeah, thanks, Matt. And thanks to you and Javier for all your contributions to getting this up and running. And a huge thanks to all of the students that have been supporting the groups today and giving extra time to plan this out at the Partners for Action at University of Waterloo. This is a really cool partnership that just kind of happened just because there's a lot of helpful people over there. So really grateful for all of your help today. And big props to Lena and Watershed Watch And then finally, just a call out for our funders, the Salmon Restoration Innovation Fund, who support the Resilient Waters Project and this work as well. So yeah, just very happy to have you all. We'll get some invites out soon for the next workshop, likely to be on barriers and culverts essentially, and prioritizing streams in your local waterways. But otherwise, I hope you have a great rest of your Thursday and a nice weekend, and we'll leave it at that. If you're from the organizing group, feel free to stick around for a little debrief. Otherwise, thanks for coming today, and we'll see you next time.